Welcome. Today I'll be doing Laplace transform, but first let me go ahead and define the Laplace transform. The Laplace transform of a function of time t, where t is strictly greater than 0, is the transform of the function of time to the function of s. We can also define it in terms of the integral between 0 and positive infinity, the function of time times exponential raised to the minus s dt, where the integral has to be over 0 and infinity, and I'm stressing the 0 and infinity. So the integral has to exist. We have some useful formulas that we need to know when we're doing the Laplace transform. We have the exponential function to become 1 over s minus a. We also have the Laplace transform of 1 is equal to 1 over s. So it means that if I have the Laplace transform of e to the minus 3t, I just gave you that the Laplace transform of e to the at is 1 over s minus a. So if I have e to the minus 3t, then we're saying that a is equal to negative 3. So the Laplace transform of this would be 1 over, replacing this a with negative 3, so it'd be s minus 3. So in other words, the transform of this is 1 over s plus 3. If I have the Laplace transform of e to the 2t, then it means that the transform of this will be 1 over s minus 2, since we know the transform of e to the at is equal to 1 over s minus a. We also know that the transform of 1 is 1 over s. So if I transform 2, some persons will automatically say 2 over s. Well, others like to break it down where you know that this is 2 times 1. And then we can factor out the 2. So it's really the Laplace transform of 1. So this is 2 times 1 over s to give me 2 over s. We also know that the Laplace transform of t raised to some power will be n factorial over Sn plus 1. And we know that the transform of sine at is a over s squared plus a squared. So I'll be looking at the Laplace transform formula number 3, where we have the Laplace of t to the n equal n factorial over Sn plus 1. So if I ask for the Laplace transform of t squared, then it will be 2 factorial over s to the 2 plus 1. Now 2 factorial is 2, and this would be 2 plus 1 to give me 3. I could also have t to the 4. So I will have 4 factorial over s to the 4 plus 1. Now 4 factorial is 24 over s, which is to the 5th. Now, say for example, you didn't have your calculator to calculate what is 4 factorial. This is just to remind you that 4 factorial is the same thing as 4 times 3 times 2 times 1. Still arrive at 24. So it means if I add 5 factorial, then you'll have 5 times 4 times 3 times 2 times 1. So if we have the Laplace transform of sine AT, which I've already stated is a over s squared plus a squared. Then if I have Laplace transform of sine 2t, first identify my a. So my a is 2, so it means I'll have 2 over s squared plus 2 squared. So it is 2 over s squared plus 4. So in this case, if I have sine 3t, then a is equal to 3, and the Laplace transform of sine 3t will be 3 over s squared plus 3 squared. So this will be 3 over s squared plus 9. We also have the hyperbolic sign to be a over s squared minus a squared, and cos at to be s over s squared plus a squared. So just to remind you that the Laplace transform of sine at is a over s squared minus a squared. So if I ask for the Laplace transform of sine 4t, then it means it will be 4 over s squared minus 4 squared. Remember, a is always in front of the t, so that means this will be 4 over s squared minus 16. So if I ask for the Laplace transform of cos 3t, reminding you the formula, so sine of the hyperbolic sign has a in the numerator, but for the cos, we have s in the numerator. So a is 3, so the Laplace transform of this is s over s squared plus 3 squared, which is s over s squared plus 9. So if I have the Laplace transform of cos 2t, you should be seeing my a is 2. And since the a is 2, then it means I'll have s over s squared plus 2 squared, which is equal to s over s squared plus 4. Finally, the hyperbolic cos is s over s squared minus a squared. So if I have the Laplace transform of the hyperbolic cos 4t, here we can identify that a is equal to 4. So it means that answer the s over s squared minus 4 squared. So this is s over s squared minus 16. So if you like, you could pause the video and do this activity first, then compare your answer. Let's get into it. So we know that the sine 3t from the formula that was listed before, it is 3 over s squared plus 3 squared. We also know that hyperbolic cos 2t is s over s squared minus 2 squared. Now, remember, how did I know it's 2? Because the a is in front of the t, so the coefficient of t is 2, so that's why I have a 2 square here, while the coefficient of this t for the sign is 3, so that's why I have the 3 right here. Now, squaring 3 squared, we have 9, and 5 3s 15. Multiplying 4 times s gives you 4s, and 2 squared to give me 4, and that's it. Let's look at another activity where we're going to find the Laplace transform of 2t cubed minus 3 plus hyperbolic cos 3t. Again, from the previous formulae that we just discussed, we know that t cubed is 3 factorial over s 3 plus 1, while the transform of 3 is 3 over s. Remember, I did it where 3 is the same thing as 3 times 1. Also, we have the hyperbolic cos 3t will be s over s squared plus 3 squared, which is 9. Simplifying this, we have 3 factorial, we know that is 6, and 6 times 2 to give me 12, and then 3 plus 1 to give me 4, and everything else remains as is. That's it. Now we're going into the differentiation theorem, where the Laplace transform of a function ft times t raised to the power n is basically finding the derivative of the transform function of ft multiplied by -1 raised to the power n, where n represents the power on t. Activity, we're going to find the Laplace transform of t times the hyperbolic cos t. First, we have to find the transform of the hyperbolic cos t. So the transform of the hyperbolic cos t is s over s squared minus 1. And because this t out right here has a power 1, that is why we have -1. And we could have written a 1 here, but it's not going to affect the -1. Now we're going to differentiate this function. You could have used the product rule, where you'd carry the s squared minus 1 to be beside the s, so it becomes s times s squared minus 1 to the -1. But you'd have to do product rule and chain rule. So to avoid these two, we just can apply the quotient rule. Now, looking at this, we can assign u to be s and v to be s squared minus 1. Let me remind you, or you can go back to my square in the denominator, and in the numerator I have v u prime minus u v prime. And this is the quotient rule that I'm going to apply. You can revisit my video on quotient rule. So applying the quotient rule, I'm going to have s squared minus 1 all squared. So that's my v all squared. Then we're differentiating the u. So the derivative of u is 1. So 1 is not going to affect anything. We'll have u prime v. So u prime would be 1, and then v would be this s squared minus 1. Then the formula has minus. Then we have the derivative of s squared would be 2s, and then multiplied by this s, that's why I have 2s squared. Now, if you're still not seeing this, don't worry, I'm going to do it on this whiteboard. So I'm going to differentiate s over s squared minus 1. So we said u is s, and v is s squared minus 1. So if I differentiate the s, I will have 1, and I differentiate the s squared, so I'll have 2s. So substituting into this formula, which I've showed you before, I will have my u prime to be 1, my v to be s squared minus 1, my v prime to be 2s, and my u to be s, all over s squared minus 1, all squared. So multiplying this, 1 times the s squared minus 1 is going to give you s squared minus 1. S times 2s gives you minus 2s squared. And we have s squared minus 1 all squared. So that's what I have on the slide. So let's get back to it. Subtracting these two, we'll have a minus. So it will be negative 1 minus s squared, for you to subtract s squared minus 2s squared. But because of this negative, it will change this to positive. Let's look at another example. Here we have Laplace transform of t squared sine t. Now, in this case, we have to differentiate 2 times because the power here is 2. So that's why I have negative 1 all squared because n is 2. And we have the second derivative to mean that I have to go ahead and differentiate this 2 times. Can use quotient rule as the previous example that I did, or we can use chain rule. Now, applying chain rule, it means that I can rewrite this as s squared plus 1 to the negative 1. And if you realize this part disappears because when I square this, it becomes positive. Now I have to differentiate this twice. So applying the chain rule here, we differentiate the outside. So we carry the negative 1 in front and subtract 1. Then we differentiate the inside, so we'll have 2s. So in other words, I have s squared plus 1 to the negative 1. Applying chain rule, we carry the negative 1 in front. Then we subtract 1 from the power, so we're differentiating the outside. And remember, you can always review my video on chain rule. And we differentiate the inside, so differentiating the inside, we'll have a 2s. So minus 1 times 2s to give you negative 2s. Then we have s squared plus 1 to the negative 2. This is what I have on the screen. Now we can go ahead and differentiate this one more time. And we're going to apply product rule because we have two functions of s being multiplied. So we have to apply the product rule. Just to remind you, and if you don't remember product rule, you can revisit my video. It's uv prime plus vu prime. So it's uv is equal to uv prime plus vu prime. So assign any one to be u and one to be v. We assign u to be negative 2s and v to be s squared plus 1 to the negative 2. So differentiating minus 2s, we have negative 2, leave the v alone. Then we hold u, so we have u to be minus 2s. But this part, when you differentiate this, you have to use chain rule. So let me explain what's happening. Applying chain rule will carry down the negative 2. So you'd have a negative 2. Then you differentiate and you'd have negative 2 times 2s. Then you subtract 1 from the power, so you'd have a minus 3. So negative 2 times 2s will give you a negative 4s. But remember, this is a negative 2s. So the negative and the negative makes it become positive. So that's why you're not seeing any negative signs here. Then simplifying this, because this has nothing to simplify, we'll have 4s times 2s to give you 8s squared. So in other words, just in case someone is still not understanding what's happening, if I have y prime to be minus 2s times s squared plus 1 to the minus 2, I'll assign u to be minus 2s and v to be s squared plus 1 to the negative 2. So my u prime here will be minus 2, but my v prime, I have to apply chain rule. So you carry the negative 2 in front, then you subtract 1 from the power, so you have negative 3 s squared plus 1. Then you differentiate within, so we have 2s. Then simplifying, we'll have minus 4s, because negative 2 times 2s, that's negative 4s. Then s squared plus 1 to the negative 3. So y double prime is equal to u prime, which is negative 2, and my v, which is s squared plus 1 to the negative 2, and my u is negative 2s, and my v prime is minus 4s, s squared plus 1 to the minus 3. So this is minus 2 s squared plus 1 to the negative 2, and this is what I'm talking about. The negative times negative become positive. So 2 times 4 will give us the 8, and s times s gives you s squared, and then this is s squared plus 1 to the negative 3.